Look up at the sky. What do you see? Clouds, the sun, maybe the moon. But what if I told you there are massive, invisible rivers flowing right above our heads? Rivers that dwarf the Amazon, carrying more water than the Mississippi, yet they're made entirely of vapor. These are atmospheric rivers, and they are one of the most powerful and misunderstood weather phenomena on our planet. Imagine Earth, as seen from space. It's a beautiful blue marble, covered in oceans and clouds. Now, picture long, narrow corridors of concentrated moisture being drawn from the warm, tropical oceans, and stretching for thousands of miles across the globe. These aren't just wisps of clouds. They are superhighways for water vapor, channeling immense quantities of moisture through the atmosphere. They are literally rivers in the sky. So, how do these colossal structures form? It all starts over the warm waters of the tropics. And so, as the sun heats the ocean, water evaporates, rising into the air as vapor. This moist air gets caught up in strong, low-level winds, which act like the banks of a river, guiding the flow of moisture. Instead of flowing over land, this river flows through the lower atmosphere, typically a few kilometers above the surface. To give you a sense of scale, a strong atmospheric river can be over 2,000 miles long and a few hundred miles wide, and the amount of water it transports is staggering. A single atmospheric river can carry a volume of water vapor equivalent to 15 times the average flow of water at the mouth of the Mississippi River. Think about that for a second. An invisible river, carrying the water of 15 Mississippis, flowing silently above you. For a long time, we didn't even have a name for them. Scientists knew these moisture plumes existed, but it wasn't until the 1990s, with the help of new satellite technology, that we could truly visualize and understand their structure and significance. The term atmospheric river was coined to capture their river-like shape and function. Perhaps you've heard of one of the most famous examples, the Pineapple Express. This is a specific atmospheric river that originates near Hawaii, hence the pineapple, and streams directly towards the west coast of North America, bringing heavy rain and snow. But there are many others all over the world, from the coasts of Europe to the shores of South America and Australia. Now, you might be thinking, a river of water in the sky sounds like a good thing, right? And you'd be half right. Atmospheric rivers are a classic double-edged sword. On one hand, they are absolutely vital for life in many parts of the world. On the west coast of the United States, for example, they are responsible for up to 50% of the annual precipitation. They are drought-bust. Picture a landscape that's been parched for months. The ground is cracked, reservoirs are dangerously low, and farmers are struggling. Then, an atmospheric river makes landfall. The sky opens up, and a steady, soaking rain begins to fall. Not for a few hours, but for days. This is the kind of rain that replenishes groundwater, fills lakes and reservoirs, and builds up the mountain snowpack, which acts as a natural water storage system, melting slowly in the spring and summer to feed rivers and streams. In this sense, atmospheric rivers are like they turn brown hills green, nourish forests, and secure the water supply for millions of people and entire ecosystems. Without them, regions like California would be much drier, facing chronic water shortages. However, there is a dark side to these celestial rivers. When they are particularly strong, slow-moving, or arrive back-to-back, the results can be catastrophic. The Same life-giving rain, when delivered in overwhelming quantities, can trigger devastating floods and landslides. Imagine that steady, soaking rain again. But this time it doesn't stop. It intensifies. The ground becomes saturated, unable to absorb any more water. Creeks and rivers, once thirsty, swell over their banks, inundating towns and cities. The water rises quickly, turning streets into canals and forcing people to evacuate their homes. This is the destructive power of a major atmospheric river event. The danger isn't just from flooding. On steep, saturated hillsides, the immense weight of the water can cause the soil and rock to give way, triggering fast-moving and incredibly destructive landslides. These debris flows can sweep away homes, block roads, and pose a lethal threat to anyone in their path. The very same phenomenon that ends a drought can, just a few days later, create a natural disaster. Scientists have even developed a rating scale for atmospheric rivers, similar to the scale used for hurricanes, ranging from Category 1, which is mostly beneficial to Category 5, which is primarily hazardous and can cause billions of dollars in damage. This highlights the dual nature of these events. They're both a blessing and a curse, and the difference often comes down to intensity and duration. So, how do we prepare for something that can be both so helpful and so harmful? This is where modern science and technology come into play. Predicting the path and intensity of atmospheric rivers is a major focus for meteorologists and climate scientists. They use a sophisticated network of tools to monitor these systems. It starts with satellites, which give us the big picture from space. Satellites equipped with special sensors can measure the total amount of water vapor in the atmosphere, allowing scientists to see these invisible rivers and track their movement across the oceans. But satellites can only tell us so much. To get a more detailed look inside an atmospheric river, scientists need to get up close. This is where Hurricane Hunter aircraft come in. These specially equipped planes fly directly into the heart of atmospheric rivers over the Pacific Ocean. As they fly through, they release devices called These are small instruments packed with sensors that measure temperature, humidity, and wind speed and direction as they parachute down through the atmosphere to the ocean surface. The data they collect is transmitted back to the plane in real time, giving forecasters a detailed, vertical profile of the storm's structure. This information is then fed into powerful supercomputers that run complex weather prediction models. By combining satellite observations, aircraft data, and ground-based weather stations, these models can forecast where an atmospheric river will make landfall, how much rain or snow it will drop, and how long it will last. This forecasting ability is crucial. It gives emergency managers, water resource officials, and the public several days of lead time to prepare. It allows reservoir operators to make space for incoming water to prevent flooding, and it gives communities time to issue warnings and evacuation orders if necessary. The study of atmospheric rivers is a rapidly evolving field. As our climate changes, these phenomena are expected to change as well. Research suggests that a warmer world will lead to more intense atmospheric rivers. Because a warmer atmosphere can hold more moisture, this means the potential for both beneficial rainfall and hazardous flooding could increase in the future, making the work of these scientists more important than ever. In the end, atmospheric rivers are a powerful reminder of the complexity and interconnectedness of our planet's systems. They are a perfect illustration of how something invisible can have a profound and tangible impact on our lives. They are the sky's circulatory system, transporting life-giving water across vast distances, shaping our landscapes, and defining the climates of entire regions. They are both a vital resource we depend on and a potential hazard we must respect and prepare for. The next time you're in a winter storm, especially on the West Coast, take a moment to think about where that rain or snow came from. It may not have evaporated from a local lake, but instead traveled thousands of miles in a massive, unseen river flowing high above your head. Understanding these incredible rivers in the sky is key to navigating our future on this dynamic and ever-changing planet. Thanks for watching. If you found this journey into the sky's hidden rivers interesting, be sure to like this video and subscribe for more deep dives into the wonders of our world. See you next time.